Alright, first off I want to say welcome back to the tutorial. Thanks for following along. This is Jesus Christ, and what we're going to do in this tutorial, we're going to cover page 69, 70. We're going to start at that page 69 and 70. We're going to cover the programming of a plain red cube. A plain red cube. Now if you look in the PDF document that came along in the first video, this is what we're looking to achieve: a black screen with a red box. Now you won't be able to move around in it with WASD, and I know you want to get to that, but we have to take these steps a little bit at a time, because if you try to rush yourself into the more advanced things, you won't learn so much, and you'll probably come across a lot of errors and issues. Okay, so we'll get to that point, but we're starting here at program 4.1, the plain red cube. Okay, this is going to be on page 69 and page 68. Okay, so just make sure you read through this. It's just a little bit. You don't really have to read the syntax, because we're going to be reading the syntax and the computer programming language throughout the tutorial. So when you get some time, just go ahead and read through here. We'll definitely be utilizing our utils.cpp file and utils.h. Read that. Just go ahead and read this. Okay, and it tells you what every single line is doing, and gives you a description or an explanation on what we're achieving, and it goes into details about what we're doing. Okay? This is what your code should look like right now. And if you run it, you should have a triangle. Oh, there's an error. Oh, I forgot to change my compiler back to 32. X32 tdm.gcc. Click OK, and we should get a blue. And if you run it, you should get your triangle going left and right. Okay, so we're going to go ahead and work on programming our red cube. Let's get started. Now, you're going to go, oh, I forgot to show you code. Okay, and this is the code that you should have. Okay, so now we'll go ahead and we are going to start with adding extra includes. And the first include that we're going to add is include C math. Okay, this defines a symbol. This defines symbols in the STD namespace, and may also define symbols in the global namespace. Includes the standard C library header math.h, and adds associated names to the STD namespace. Okay, so CMath is kind of similar to math.h. Anything, I think I should include that too, but it's not really telling me to. Nah, you know what, I'm not going to put it in there, because it doesn't tell us to. And the next line that we're going to put is include GLM. Okay, we're definitely going to need our GLMs. And do I have that included already? Okay, don't worry about that. Don't do anything I just did. Okay, just worry about not include typing, because I'm definitely going to be setting this up so that we can come across errors and you'll know what to do for each one. Okay, so you want to make sure that you add your include GLM, and with your GLM you're going to have a lot of different various GLMs. You're going to have GLM HPP, and if you want beneath that. Okay, we'll go ahead and include them right now. And we want to add include GLM GTC type _PTR.hpp. Okay, that's a HPP file. You're definitely going to need that as well. We're also going to need this GLM as well, which is GLM GTC matrix transform. We'll run a rebuild and it's asking for it. Okay, so we'll get to that later. As a matter of fact, we can include it right now. So let's go ahead to this website right here. And we're going to download our GLM. Okay, it pretty much explains and it describes to you here what GLM is. Okay, we're going to code. We'll download zip. We'll wait for it to finish downloading. We'll go in our downloads folder. We're just going to go ahead and extract. And we're going to delete GLM master zip. We're going to take our GLM master and we're going to rename it GLM. We're going to go ahead and drag it into our root main folder. We're going to go into OpenGL because we need to set it up so that it's reading that folder, because when we rebuild it's asking for it. So in situations like this, we're just going to give it to you. We're going to give it to the IDE, which is CodeBox. Compiler. Search directories, compiler. Going to add. Click our blue folder. Here's our GLM. Select folder. keep this as a relative path. Click yes. OK. And it's showing up there now. So we'll click OK. Is it still asking for it? No, because it hasn't. Okay, so now we're going to go and add some more lines. Include utils.h. Run a rebuild. It's asking for soil 2. Now, we don't really need soil 2 right now, but we'll go ahead and give it anyway. And it's asking in the utils.h. Okay, so what we're going to do, we're going to go to OpenGL. And we're going to give it soil. I'm going to go search directories. Oh, I'm sorry. Okay, so since it's asking for soil, we want to be sure, we want to make sure that we're including it in our include folder. Okay, so we'll go into our Spartan J soil 2 master, and we'll right click and include in our soil 2 master, and we're going to copy it. We're going to go back, we're going to find our include folder, and we're going to paste it. Mine is already there, but if yours is not there, you won't be seeing this. I'm going to go ahead and click replace the file in files destination because mine is already there. We'll check to see if it's still asking for it now. It's not asking for it anymore because it's already there. Okay, and this is the utils. Okay, so now what we want to do, it's going to be asking for the utils.h. But when it asks for that, then we'll go ahead and take care of that. Okay. Okay, so you want to make sure you add all these things right here. Include CMath, include GLM. These are GLMs, and you need those, and you want to include your utils.h. And what is your utils.h? Utils is associated with the .cpp file. This is your utility header file that has required reusable functions. Okay. So now we're going to go underneath our define num VAOs, and we're going to add define num VBOs. VBOs stands for vertice buffer objects. And in this case, we're defining 2. The define creates a macro, which is the association of an identifier or parameterized identifier with a token string. After the macro is defined, the compiler can substitute the token string for each occurrence of the identifier in the source file. Okay, it has to go all the way over there for that. So now what we're going to do, we're going to go ahead and remove these two right here. We're going to go beneath your define num VAOs, okay, because we're defining these two right here. We're defining number VAOs and VBOs. And we're going to go ahead, I don't want to say we'll delete them, we'll cancel them out. because we're not going to need these anymore. We're going to need GLUint rendering, but what we'll do is we'll just retype it in the correct order that it's supposed to be typed in. And after that, we want to type utils, util equals utils, semicolon. Parentheses and semicolon, I'm sorry. Now we're going to type float, camera X, camera Y, and camera Z. Those are commas. If you want to know what a float is, I think I've explained that to you already. We'll just go to this website. I don't feel like reading it to you. I will read it, but I won't read it to you. I won't read it to you. So I like to read to myself.
Float is a shortened term for floating point. By definition, it's a fundamental data type built into the compiler that's used to define numeric values with floating decimal points.
Okay, so if you can go ahead and do that if you don't feel like reading it out loud to yourself. That explains to you what a float is. Now we're going to float cube log X, cube log Y, cube log Z. GLUint rendering program. GLUint is an unsigned binary integer of 32 bits. Don't forget your semicolons. GLUint VAO, number of VAOs, semicolon. GLUint vertex buffer objects, number of vertex buffer objects. I'll explain to you what VAO and VBO is, so you should already know what that is already. GLUint model view loc, projection loc. This is model view and projection perspective location. Int width and height. Semicolon, don't forget your semicolon. Float aspect. Graphics library math. Mat4, PMAT, comma, VMAT, comma, InMat, comma, model view mat. So P stands for projection matrix, V stands for view matrix, M stands for model matrix, and MV stands for model view matrix. Semicolon. Okay, so now we want to do void setup vertices. Void. This pretty much speaks for itself. This line sets up your vertice locations, your verts, your points in 3D space. And in between these brackets, these curly brackets, we're going to put 108 vertice locations. So it should look like this. I'm going to tidy it up a bit for you. Well, if you want to do that, a little special move right there, you want to go up to settings, compiler, no, I'm sorry, editor, general settings. You want to double click these two down here. You want to allow multiple selections, make sure they're both checked. Allow multiple selections, enable typing in multiple selections simultaneously. Click OK. And in situations like this, you want to hold Shift and Alt and use your up or down keys or your left or right. You can use spacebar or backspace to adjust, like so. Okay, so now, that's what we're going to do. We want to go beneath this semicolon and beneath this curly bracket down here, and you want to type GLGen vertex arrays. This will generate vertex array object names for you. And there's VAL right down there. GL bind vertex array. This will bind a vertex array object for you. GLGen buffers num VBOs, comma VBO, semicolon. This will generate buffer object names for you. GL bind buffer. Okay, this pretty much speaks for itself. Also, this will bind your buffers. GL array buffer. GL buffer data, GL array buffer, size of, vertex positions, GL static draw. Okay, this creates and initializes a buffer object's data store. Okay, so that's all for that section. Let's go clean up a bit. We're going to scroll down to our void init. I'm going to take this out right here. And for our red cube, we're going to start up a different void init. Okay, so you want to make sure that you have your curly brackets there and there. This is void init GLFW window star window. This is pointing to our window that we're going to be working with. Okay, we canceled out this one and we're going to create a new one. This is what you want to type. Rendering program is equal to utils : create shader program. These are your shaders right here. Of course, we need to keep those linked up. Make sure we keep them linked. Make sure we don't mess anything up. Because if you do, you're just going to have to start all over. And don't forget your semicolon. Because I tend to forget them. Camera X is equal to 0.0f semicolon. Camera Y is equal to 0.0f semicolon. Camera Z is equal to 8.0f semicolon. Okay, so this right here is represented. This line right here is a representation of where you're going to place your camera. Okay, it's going to be on Z 8 units on the Z axis. Okay, so if you want your camera to be further away from the cube, you're probably going to have to put -8, but we're not going to do that now. We're going to wait until we get our cube rendered, and then we'll go ahead and play around with the camera. Cube location X is equal to 0.0f semicolon. Cube location Y is equal to -2.0f semicolon. Cube loc Z is equal to 0.0f semicolon. Okay, so this represents the location of the cube. It's going to be on the y-axis, two units on the y-axis. I'm sorry, -2 units on the y-axis. So if you want this to be further away from you, probably going to have to make it a +2 instead of a -2. We're not going to change that up. We'll wait until we'll start to see our cube. Set of vertices, parentheses, semicolon. Are those parentheses? I think they're brackets. I don't know. Okay, so that's for our void. Okay, this one we don't need. We're canceling it out. You can delete it if you like, but I usually like to keep it around for a while until I know for a fact that we have something rendered and something is working. Okay, so now we're going to go down to our use program. And we're going to remove float. I'm going to remove our float X and our float ink. Okay. And we're also going to remove this as well. And we're going to remove this. Okay, you don't want to remove GL point size, and you don't want to remove GL draw arrays. Keep those there. We're going to keep our GL use program there also. You're going to type GL clear GL depth buffer bit above our GL use program. We're going to go beneath our GL use program. Don't forget your semicolon. Then we're going to go beneath our GL use program. We're going to type GL use program. No, I'm sorry. We're going to type mvlog. MV location, model view location, GL get uniform location, rendering program, MV matrix, semicolon. And we're going to type projection location is equal to GL get uniform location, rendering program, projection matrix. We'll type GLFW, get frame buffer size, window, comma, end width, end height. Just trying to speed things up a bit. We'll type aspect equal to float width divided by float height, semicolon. Type projection matrix is equal to graphics library math : perspective 1.0472 float, comma, aspect, comma, 0.1 f, comma, 1000.0 f, semicolon. That's what you want to type next. And then after that, that's what you want to type. V matrix and M matrix. V stands for view, M stands for model. Don't forget your semicolon. Okay, next you want to type MV, which stands for model view matrix, is equal to view matrix times the model matrix. Next you want to type GL uniform matrix 4FV projection location 1 GL false GLM value PTR P matrix, semicolon. It's going to speed things up. Alright, so that's what you want to have. You could pause the video You go back, take a look at what you need to type. We're going to go ahead and move on. Now what we want to go into our vert shader. And we're going to remove a uniform float offset. And beneath version 430, we're going to type this. Layout location equal to 0 and vec3 position with a lowercase p and semicolon. Then you want to type uniform mat4 model view matrix semicolon. Then you want to type uniform matrix 4 projection matrix semicolon. We're going to go ahead and get rid of this right here. And we're going to put this line, GL position with a capital P equals projection matrix with a lowercase p multiplied by MV matrix multiplied by vec4 position with the lowercase p comma 1.0 semicolon. That's for your vert GLSL file. Now we're going to go to our frag GLSL file. You want to type beneath this line uniform mat4 MV matrix you want to type beneath that line uniform mat4 projection matrix. We'll take this line out, we'll add a new one. It's going to be somewhat similar. Color is equal to vec4 1.0 comma 0.0 comma 0.0 comma 1.0. Okay, so we went from blue to red. All you had to do is just make this a 0.0 and make this a 1.0. So this is where you go about changing your color of your cube. Alright, let's go and see what we have. We're going to rebuild. It's asking for utils. Undefined reference to utils create shader program. Okay, why is it asking for this? Because we didn't bring in our utils.hpp and our utils.cpp. So we're going to go ahead and go in our project location and right click OpenGL. We're going to go add files and we're going to click on utils and we're going to hold control and click on the utils.hpp file. So okay, so this is a CPP file and this is a header file, You want to click open and click OK. And let's try it again and see what it says. Okay, so now it's asking for soil. In situations like this, we're not going to need soil because we're not working with textures yet, but we will go ahead and set it up since it's asking for it right now in the utils.cpp file. You can see right there. But there's a little trick that we could do. We could just cancel these lines out and it will run. We can cancel it out and it's gonna run. It's giving us a warning. Okay, so we do want to take care of our soil. Okay, so where do you get your soil from? You can get it from GitHub. You can get it from Bitbucket here. But you're going to have to go about setting it up in a certain way. So I'm just going to include my soil. Let me give it to you. But this is where you get soil from. Download zip there. Download repository. Okay, and there it goes. Show in folder. Spartan J soil. Oh, see, the files are not even there. It's best to just use mine. I'll have it all set up for you and I'll make it downloadable. Okay, so this is asking for soil. Okay, so what we're going to do, that's for the soil library. Okay, so we need to link it up in the libraries. Right click, go into build options, open GLTut, linker, add. We're going to find our libsoil.a file. It's going to be in our inklib folder, lib, and there should be a libsoil file .a file there. If it's not, what you want to do, you want to locate your Spartan J soil master folder. You go on your lib. You want to copy the libsoil.a. Go on inklib and copy your soil there. Paste it, I'm sorry. So now it's showing up there in your lib. So now we'll go back in there and we want it to be in sync with all these right here. So we'll click our add, click your blue folder, and we'll go locate our lib folder. Lib, there it is right there, libsoil.a. You want to click open, keep its relative path. Yes, has been working for me. Click OK, click OK, and we'll run it, or we'll rebuild it all the way through. It's not even doing it. Okay, so what's the problem here? Undefined reference to GL read pixel. Okay, so why is it doing this? There it goes right there. It says libsoil.a. There's a problem with it. See, soil.o, soil.a. There's a problem with it. Okay, so how do we fix this? Okay, so we go in our build options again, open GL Tut, linker setting, you go down in our soil. You don't want it at the bottom, okay? When you're working with soil and you have your soil part of your libs, it has to be all the way at the top. Okay, so what you want to do is you want to click on it, you want to move it all the way to the top, all the way up, all the way up. Click OK, and let's run a rebuild to see what it says. Oh, it gives us blue. Let's keep your fingers crossed. And what do we get? Oh, get a red triangle. Give me a minute, let me find out what's going on with this. Okay, what I forgot to do was change the GL draw arrays. So cancel out the GL triangles and add GL triangles 36. So you need GL draw arrays, GL triangles, comma 0, comma 36, semicolon, and you should get a cube. There you go. Okay, so that's your cube. We'll go ahead and save project. We'll save everything. And then I'll see you, I guess, in the next vid. In the next vid, what we're going to do, we'll add some color to it. And we'll probably give it a tumble, depending on how I feel about making a tutorial. But that's what we were supposed to accomplish in this tutorial. You go ahead and read through page 69 from page, I'd say 68, 4.5, all the way down. You read all the syntax that we've covered, and it will give you an explanation on what you have accomplished and what you were going through, what you were typing and everything. The reason why I do these tutorials is because when you open this book or when you look at this PDF document, you have a tendency to get overwhelmed by having to read all this syntax, and then you have to turn around and do more reading, and you have to read the descriptions or what the professor or the writer of the book, the author of the book, is saying. So there's so much reading that you have to do, but it really helps. The syntax, the reading helps, the book helps, but what helps even more is when you have a video tutorial that's explaining to you where to put this stuff, where to put your code, where to put your lines of code. Because when you open the book and you read all the syntax, sometimes, you know, people just don't know exactly where to put the code, you know, with the semicolons and the dots, and, you know, add this line, add that line, but they just don't know where to go with it. So video tutorials do help. People don't get as much, depending on what kind of learner or what kind of listener the programmer is. You know, people don't get as much out from a book, reading a book, as much as they do from actually watching a video tutorial. Okay, so that's why I do video tutorials, and also because it actually helps me when I, you know, go back and I watch these tutorials. I'm actually learning from myself, you know, and it really helps me also. So it does. If it helps me, then I'm sure it's definitely going to be able to help you. So that's it for this tutorial. I'm not going to go on and keep on talking. Definitely go back. Hopefully you've accomplished what you were supposed to accomplish in here. You know, for first-time programmers, or I guess people that don't have much time programming, maybe you've been programming for only maybe 2 weeks or 2 months or maybe 6 months and everything, you still just haven't gotten it yet. But if you haven't accomplished this, maybe you need to go back and just do it again. Maybe you make a couple of, maybe you made a mistake or two like I did. I had to pause the video and go back to see what I did wrong. I did make a mistake, but I actually found my mistake. Probably took me about like 5 minutes, 8 minutes to find the mistake. So even if you have to go back and do this tutorial maybe 4 or 5 times until you actually get that red cube, don't forget your semicolons. And that's probably why your cube isn't showing up, is because you forgot to put something, or maybe you typed something wrong. Maybe you put a lowercase c or a lowercase p or uppercase p when it was supposed to be lowercase. Maybe you put a lowercase p when it's supposed to be an uppercase. You know, those little itty bitty errors like that, and you know, those little errors can, you know, affect your game or affect your little 3D application that you're typing up. Okay, so make sure you type everything correctly into a T. And don't miss anything. Don't miss any commas. Don't miss any colons. You know, don't miss any semicolons, and you should get outstanding results. This is Jesus Christ. Thanks for watching this tutorial, and I'll see you in the next one. Have a good night. Thanks for watching.